Okay, thank you very much. I appreciate the opportunity to be here this evening. I'm not sure that everybody knows the phrase snafu, right? That title's a snafu. I'm not going to talk about any of that. So they gave me a bit of a carte blanche, and somebody put a placeholder in. And tonight I'm going to talk a little bit about what the new science tells us about the reasons for the weight loss plateau that we all see in the clinic, and the counter-regulatory systems that seek to increase body weight and to prevent our therapies from actually working. And that applies both to the medical therapy, dietary therapy, and also, in some instances, but not all, certainly, surgical therapy as well. So let's see if I can get this to actually work here. So to start out with, I just want to introduce my disclosures here. I do pharmacotherapy, drug discovery and development, so I'll put my disclosures up here. I want to talk a little bit about our research institute in Orlando, Florida. Everybody knows Mickey Mouse, Harry Potter, all of that. If you're ever in Orlando, please look us up. Our goal is really breakthrough treatment for a variety of metabolic diseases. We work in obesity, adipose tissue, diabetes, aging, and have started a program several years ago in NASH and NAFLD. And we use clinical approaches. I'm not a mouse doctor. I love our mouse doctor friends. They're very important for some things, but not so important for others. And we work in the area of trying to quantify the energetics of weight loss and weight gain and regain. So this came out just recently. I'm not really sure what this means other than he's obviously android, and she's very gynoid. And if you want to put this in your slide deck, just go to the New Yorker. You can pull this down. It exemplifies a couple of other things, too, and that is everybody has an opinion about obesity, and as practitioners in the room, you certainly have heard that as well. And I'll give you my own opinions, but hopefully we'll have that based upon the science and not just on hope and kind of what we believe. Now, I'm not going to go through the pharmacologic therapy, but I am going to talk a little bit later on about how this problem of weight loss and weight loss maintenance is controlled actually in large part by physiologic rather than behavioral systems. And I put this up here just to make sure that if you have any interest at all, that there are good resources on the pharmacologic side, and that includes the TOS guidelines for non-pharmacologic management, which were published in 2014, and then a document that is going to be updated, which is the Endocrine Society Clinical Practice Guideline, which came out just a couple of years ago, and this will be updated very soon, so I would just refer you to those as well. So everybody's seen this. This is actually a fairly good weight loss curve from either diets, drugs, or what have you. And the weight loss plateau that we see, I think, is really a problem for all of us in the clinic, and it has, if you will, both endocrine and physiologic mechanisms that are causative, and I want to go through some of those mechanisms so that we can talk about two things. One is explaining and understanding to your patients and to yourself what the heck's going on. And then secondly, begin to understand what some of the strategies that can be employed either pharmacologically, lifestyle, or otherwise to be able to offset those mechanisms. And there will be other points in here that I'll bring up that are going to be common to you and your experience, and we'll talk a little bit about what the mechanistic underpinning for those might be. So we think in terms of energy balance and in macronutrient balance, which I won't have a chance to talk about, intake, nutrient absorption and loss, which isn't talked about much, but occasionally, and then energy expenditure as well. And combined, we call that quantitative bioenergetics. And there are some fundamental questions that have been answered in the last couple of years in terms of how these control systems actually work, both on the intake side and on the expenditure side. The nutrient absorption and loss is really an area where we don't have much data in the clinic, but I can certainly answer questions about that as well. So this is a schematic representation of a very physically active individual in terms of the components of energy balance. The areas that I'd like to draw your attention to, actually, if I can get the little pointer here to work, would be this green text on the left-hand side called metabolizable energy. We now understand that fecal and urinary energy loss can be very important when it comes to the energy balance equation, and I'll show you examples here in a few minutes about how, in particular, urinary energy loss can contribute to weight loss and weight loss maintenance as well. Fidgeting. When I was in the 5th grade as a young boy, we called this poor citizenship, okay? It was the inability to sit in a chair when you're... Did anybody have this problem besides me? Okay, thank you. I actually once, about 2 years ago, had the opportunity to have my mother hand me some of my report cards from when I was in 5th grade and had multiple Fs in citizenship. Not a bad kid, I just couldn't sit still in the classroom. Fidgeting is actually inherited, and it's a major component of, for some people, of their total daily energy expenditure. And if we could find a way to pharmacologically activate fidgeting, it'd probably be good for our metabolism and body weight, but nobody would like to see a speaker who can't, hold their own still. But suffice it to say that fidgeting or spontaneous physical activity or non-exercise activity thermogenesis is critically important, particularly in the prevention of weight gain. We know that fidgeters, people with high spontaneous physical activity, tend to gain weight less over time. The other area that's important here is the ability to find ways to increase energy expenditure through exercise or volitional activity. We, by and large, in Western societies, don't spend as much energy in our daily lives as we used to, so we have to add it back. We call that exercise. I'm not going to talk a lot about that today, but suffice it to say that physical activity is great for preventing weight regain and preventing a weight gain in the first place. And we can maybe answer a little in the Q&A in this as well. So let me walk you through this, because this is a key important concept for everyone who takes care of patients in a weight loss or prevention of weight gain setting. So the dotted line here is the regression line that describes either, in this case, sleeping energy expenditure, 24-hour energy expenditure related to your lean body mass or fat-free mass. And that dotted line represents, if you took a big population of people and used any method, either DEXA or BIA or what have you, to measure fat-free mass, describing the relationship between your size and your resting energy expenditure. And again, 24-hour energy expenditure looks incredibly similar. Each of the individual symbols below is a patient that was studied very intensely in a metabolic ward after they had undergone either a low-calorie diet, LCD, caloric restriction, or caloric restriction plus exercise. And what you can see is all the dots are below the line. And that represents a reduction in energy expenditure beyond what you would predict based on changes in body composition. And we call that metabolic adaptation. How many of you were around in the days of fen-phen? Anybody ever use fenfluramine and phentermine in the clinic? Well, I kind of got broken into obesity pharmacotherapy in a fen-phen clinic. And we would always have seminar in the same room where the group sessions happened after fen-phen, and the thermostat was set on 36, okay? And that's because when people lose large quantities of weight, their metabolism drops, again, beyond what you would expect based upon their body composition, and therefore, their sensation of their own internal body temperature caused them to increase the thermostat. And this is an example of metabolic adaptation. We see this post-bariatric surgery. We see it with weight loss of modest means, okay? We actually see it within 4 weeks in some patients of enlisting in a low-calorie diet or beginning a pharmacotherapy. Now, what does that tell us? That means that people have, if you will, a counter-regulatory mechanism that's conserving calories that would then push the body weight back up. Quantitatively, the question is, how important is this versus people becoming hungry after they lose weight and then forcing energy intake to go up as well? And we'll actually address that from a quantitative fashion and give you one little pearl that you can take away with you. The other area related to understanding how and why people begin to plateau and then also are more likely to increase their body weight has to do with our increasing understanding of the neurobiology of body weight regulation. And so much of this field has been focused on the external environment, hunger cues and cognition and reward and memory and all of these other, if you will, frontal lobe functions around how we relate to food. In contrast, these environmental, memory, and other factors sit right next to key components of the brain, very deep and fundamentally old neurobiological systems in the hypothalamus and in the brainstem that control multiple aspects of food intake and hunger. So this is the relatively high-resolution MRI of a young physician scientist who studies body composition and metabolism and these sorts of things. And it doesn't look quite as atrophied as some people had predicted, but otherwise healthy brain slicing through the hypothalamus. And what we have learned from our rat doctors, and this has been, these deep centers actually have been recapitulated in the human condition, which is important to understand. Some rat and mouse studies have nothing to do with humans. This biology actually does play a role in human biology. And there are 2 or 3 nuclei within the hypothalamus that are important. The little purple circle there is a kind of neuron that's critically important for the regulation of this internal homeostatic control system. And it has certain kinds of characteristics. We'll call those here POMC or CART neurons. And then there's another class of neurons called AGRP or NPY. And importantly, these talk to other key fundamental systems like the paraventricular nucleus or the lateral mediobasal hypothalamus that can either turn off hunger or can turn on hunger. And these yin and yang systems we use as targets for our pharmacotherapies, okay? And I'll show you some examples of that here in just a few minutes. The other neurons, the POMC CART neurons, are incredibly important because they flip the switch in the other direction. And we know, for example, of our severe obese patients, probably 3 to 5% have melanocortin receptor 4 mutations that set this out of kilter, all right? The other important piece here is that many of the peripheral hormones that you've heard about, ghrelin, GLP-1, or serotonin receptors reside in these neurons and can then change this balance. And I'll get to the point here in just a few minutes. But these systems are incredibly important in driving hunger after weight loss and driving weight back up as well. And the reason for that has to do with the change in the enteroendocrine and neurohormonal systems. And I'll walk through a couple of these control points that have been discovered and very well worked out in the last probably 10 years or so. So amylin, coming from co-secretion of insulin in the pancreas, has specific receptors in the hindbrain called the nucleus of the solitary tract. GLP-1, I think you're all very familiar with, has receptors not only in the hindbrain but also in the hypothalamus. Oxyntomodulin, a variant of glucagon, also has the same receptors. Distal gut peptides like PYY3 to 36 in the hypothalamus. And then leptin, the fat cell hormone, also has receptors in multiple parts of the brain as well. In addition, these areas sense fuels and metabolites, and these signals, either from vagal inputs or other chemosensitive receptors in these areas, tell the body when the fuel and peptide balance is not right and can drive hunger. Now, my pleasure today was to meet Priya, who actually was the first author on this. What a wonderful young lady, an inquisitive physician scientist. And this is a very important study because you can talk about this with your patients about why they get hungry and maybe why they get cold and why it is so hard to maintain their weight loss. I think that understanding of the basic fundamental biology is incredibly important to be able to have a conversation. And what they found in this study was that these hormonal changes act to reduce energy expenditure, to turn on hunger, and to make it difficult to both lose and maintain that weight loss. So the net drive of these combined hormonal changes is to drive weight gain. And beautifully, many but not all of these are reversed with bariatric surgeries. Now, I want to shift gears a little bit in the final couple of minutes here and talk about this fundamental question: how much of the inability to maintain weight loss and to prevent weight regain is due to hunger versus the metabolic adaptation that I talked about a few minutes ago? So I'm going to take a quick survey of the room here. Okay, so everybody be ready to raise either your right or your left hand. Everybody ready? The surgeons I know can get this. The medical guys, good luck. Okay, so if you think that these energy-conserving metabolic adaptations are most important, raise your left hand. 1, 2, 3, 4. John, did you vote? He's not voting. Okay, that's all right. If you think hunger is the major problem, raise your right hand. If you're not sure, raise both hands. Okay. Well, actually, until a couple of years ago, I wasn't quite sure myself, so I'll raise both hands and I'll show you the data that I think supports this. So a clever guy up at the NIH in Bethesda, Maryland, just north of Washington, D.C., came up with a way of taking information around body weight and energy intake. His name is Kevin Hall. And he's able now to mathematically model the different components of energy balance. And he's validated his model with our data and a whole bunch of other people's data, and the model actually works. He's a physicist. Does that tell you something? He counts calories. He understands these what are so-called dynamical systems modeling. And it's uncanny how this stuff actually works. And we keep pushing the model with all sorts of perverse perturbations in the clinic, and it continues to work. So I put that reference up here. If anybody wants it, send me a note and I'll get it for you. But basically, instead of being able to take energy intake and model what happens to body weight, he can take body weight and model the differences in energy intake. And it's just physics, okay? Stuff we probably coulda, shoulda, or our juniors eventually will learn when they go to medical school. But these mathematical models, oh my. You can actually go to his paper in Lancet, which I put up here, and there's a little calculator you can pull up on the Lancet webpage that will allow you to put some numbers in for prototypical patients, and it will show you for any difference in energy balance or energy intake or expenditure, if people start exercising, what happens to their body weight. So you can kind of play with it and get an understanding of what a real-life setting would be. And it's quite clever, and it's very approachable. You just fill in some numbers. It's easy to do. But the mathematics and the validation of this has been extremely strong. So these dynamical systems modeling approaches have been very informative. And let me collapse all this down into a couple of ideas. One is that when we think about lifestyle-mediated weight loss, let's see if I can get my pointer here going. Nope, no pointer. So take the solid blue line in the bottom. If you take any diet or drug intervention, you get this check-based blue line. So in other words, at the beginning of the intervention, energy intake goes down quite a bit, and then very quickly, not months later, but weeks later, particularly for pharmacologic and other interventions, intake goes down, and then it begins to go back up to baseline. Think of those hormones and metabolic control systems that I was talking about. Now, if you eat less because the thermic effect of food is less, and because the energy cost of moving is less, the yellow line shows that your energy expenditure goes down a little bit too. Okay? So these are fundamental biological processes. if you put those together, knowing these counter-regulatory systems and calculations I'll show you in a minute, the homeostatic drive to eat goes up, right? You start losing weight and your hunger goes up, and we see what happens to energy expenditure. Again, all of this has been very well validated. So the difference between increased appetite and the actual energy intake is, if you will, kind of a hunger index. And this is where pharmacotherapy can be extremely powerful for reducing the hunger that goes along with these counter-regulatory systems. And this is where bariatric surgery is so incredibly effective. Okay, everybody with me? Let's keep going here. So I'm going to do a little thought experiment that they actually did with you, and that is taking a drug, an SGLT2 inhibitor that wastes calories in the urine as glucose, and let's say, okay, this is what happens to body weight with many but not all of the SGLT2 inhibitors, because you're peeing out calories. What happens to food intake when you pee out a bunch of calories? Any guesses? Right hand is up. Right hand, any right hands? Okay. How about no change? There's one wrong answer in the back. So remember, when your body weight goes down, counter-regulatory systems get turned on, and your drive to eat goes up. We saw that in the prior slide. Sorry to embarrass you, but it's okay. And they actually, again, using this body weight to energy balance calculators, were able to go through and model. And if you look at just canagliflozin with this study that they published last year, the increase in energy intake is about 300 kcals a day. It's not a lot, but it's remarkable. I mean, people, you just pee out calories, you eat more. Kind of makes sense. So now, for the first time, we can begin to calculate how much is this metabolic adaptation or slowing of metabolism versus hunger and driving food intake. This is a very, if you will, pure experiment in humans, unambiguous, and we now know that, again, it's about 100 calories a day in metabolic adaptation. You got 300 calories a day that increases energy intake, or increases energy intake. So that relative ratio is about 3 to 1. So when everybody talks about my metabolism gets slow and this, that, and the other, the primary drive to weight plateau and weight regain is an increase in hunger and intake. That's your big pearl. You can take that back to your patients, okay? Now, there are ways to offset the metabolic adaptation, and that is called volitional physical activity. So that 100 or 200 kcals a day, you can make up for in the energy balance checkbook of life by simply going out and moving more. And if you look at people that are successful weight loss losers over a long period of time, they are highly physically active. So this certainly meshes with that as well. Okay. In the last 3, maybe 4 slides, I hope I'm not blowing the calendar out here, John, but in terms of the agenda, I want to walk through one other concept, and that is we talk a lot about combination therapies, and the fundamentals that I've just given you over the last couple of minutes really inform how we think about combination therapy. So you can do 2 things with combination therapies, at least in pharmacotherapy or other therapies. 1, you can double down on energy intake. You can use pharmacotherapies that will additively reduce hunger, increase satiety, et cetera, okay? Or you can have one big whopper, right? You can have one big stick or one big hammer. And we've got some of those in the pipelines, and, you know, there are those in the room that know a lot about those studies that are beginning to come out, for example, with SGLT1 combinations we'll talk about, but also just more potent and effective pharmacotherapies. This is a modestly effective but very safe drug called lorcaserin. We worked on the development program for this. You've seen the curves, and you get this flattening, you know, somewhere around 6 months to 8 months. So we took Kevin Hall's model, and this is what he showed with that. Remember that blue check, energy intake goes down, and then it comes back up again. If you model that and then placebo subtract it, you're really only seeing at plateau about a 50 to 100 kcal reduction in energy intake at the plateau. It's not very much, right? So what if you could add something to that that gave you a little bit more at the end, or you could waste calories? Here's our actual measured data from the model, 300 kcals per day at about week 8. You combine Kevin Hall's read it backwards dynamical systems modeling with our data, and it's spot on. It's been validated in multiple occasions. So again, early on you get this reduction in intake that then begins to go back up. Now this is an interesting study where we took the same drug and we added to that phentermine, which has a little bit of a thermogenic effect, but also decreases energy intake. You add those together and you basically get a new fen-phen, where you're getting on the order of about 8% weight loss. And then last set of slides here, if you use canagliflozin and phentermine together, again, you're wasting calories, but you're also reducing energy intake with these two together. You get even more weight loss, and this was recently published earlier in the year. So I guess what I'm saying here is you can, again, by using combination pharmacotherapies, you can either double down on energy intake, or you can begin to manipulate energy loss with SGLT2s. You can increase physical activity. There are ways to, if you will, game the system to get more weight loss and prevent the rebound. So what's the future going to look like? I mentioned combinations here. There are a lot of folks who are working on the energy expenditure side. It's hard work because you can't do this through activating the adrenergic nervous system, because you're going to get cardiovascular complications. We know that from sibutramine, to be clear, and there are other considerations there as well. I'd like to create a drug that caused fidgeting. That seems like it might actually end up being safe, but it might get me a bad citizenship score. We're working also, and others are, big companies are getting into how do we manipulate the microbiome to reduce energy absorption without producing side effects. And there are other ways that we might be able to look into the future. But remember these fundamentals about how these systems work, and they'll help you interpret what's coming down through the pipe. So with that, I'll conclude. Invite you to Obesity Week 2017, and if you're ever in Florida to see Mickey and Minnie, come see us. Thanks so much.